In these next set of questions, what we're going to do is use the test for an AP. And as we've said before, the difference in a common difference in an AP is the second term minus the first, or the third minus the second, the fourth minus the third. They all must equal the same because they're always going up by the same amount. If they don't, then it's not an arithmetic progression. They all have to go up by the same amount. So we're going to use this test. So in this first question here, if 3x 19 are in an arithmetic progression, we know that we can take x minus 3 was the second term minus the first, and then that must be equal to the third term minus the second. So 19 minus x. So what we've allowed ourselves to do is find it as a simple algebraic equation. We start to solve that. Add x on both sides, subtract 3, add 3 on both sides. We get 2x equals 22, x is equal to 11. So 3, 11, 19. Yep, it's an arithmetic regression. It's going by 8 each time. Same thing with the next question. If this forms an AP, then 2 minus 8 must equal x minus 2. The second term minus the first is equal to the third term minus the second. So 2 minus 8 is equal to minus 6, x minus 2, which is equal to x minus 2. So x would have to be equal to minus 4. The next question, again, x is in the middle, 45, x, 99 form an arithmetic progression. So 99 minus x is the third term minus the second. It would be equal to the second term minus the first term, x minus 45. Collect our terms. 2x would equal 144, x would equal 172. And if you want to check, take 72 minus 45, it should be equal to 99 minus 72. This question is a little bit different. Find the first negative term in the AP, 98 plus 93 plus 88. So what we're looking at the situation here is that, again, if we want to identify what's the value of n, that would be negative, the first one that's going to give us something that's negative. So when something that's negative is going to be less than 0. But this time we can see that a is equal to 98, d is equal to minus 5, because 93 minus 98 is minus 5. The terms are going down. So our common difference is a negative value. So we want to see how far this goes down before it actually becomes negative. So we set up our a plus n minus 1 times d equation. And where's it going to be negative? Where's it going to be less than 0? We're just solving now a simple linear inequality. So 98, we've expanded our brackets to get minus 5n. We've got plus 5. It's less than 0. And now we're going to collect our terms. And we see that when n is greater than 20 and 3/5, we're going to have something that's going to be negative. So the first term after 20 and 3/5 is the 21st term. So if I actually do that calculation, t21, and sub it back in, so put 21 into there, I'm going to get minus 2. That's going to be my first negative term. So we just solved that simple linear inequality, but we're using that equation for the term of an arithmetic progression. This one's a little bit different again. We're just using this formula now to solve different types of questions. We're told the first term of an AP is 7, the fifth term is 23, and we want to find the 20th term. So we know a is equal to 7, t5 is equal to 23. So we know what n is, we just don't know what d is. But we've got everything else. So 23 is tn, 7 is a, 5 is n, and we're left with just d. We've got 3 out of the 4 unknowns in this equation. So again, we just simplify it out. That would give us 4d. We've subtracted 7 across, and we get d is equal to 4. Now that we know what 4 is, d is equal to 4, we've got a, we've got n, and we've got d. We can find t20, which is our 20th term of the series. But we're using that formula, and we've got the one unknown we need to find in d. In question 6, again, we're told the fifth term of an AP is 14, the 10th term is 59. So find the first term and then the common difference of the series. So if we set this up, we know that t5 is equal to 14, t10 is equal to 59. So A is the same in both. We don't know what A is, but T5 is 14, so that means A plus n minus 1, and if n is 5, gives us 4 from the 5 minus 1 times D. Gives us an equation there. It's got two unknowns. We can't solve that yet. But if we look at T10, which is equal to 59, and use the A plus n minus 1D, A being 10, that gives us 10 minus 1, which is 9. We get A plus 9D is equal to T10, which is 59. They're simultaneous equations. Pretty simple simultaneous equations because we can just subtract the A. We can say 9D minus 4D would give us 5D. 59 minus 14 gives us 45. Allows us to find D, which is 9. And if D is equal to 9, we can go and substitute it back into this equation. D is 9. We've substituted there. And then we've just got an equation with A, which we can solve to get minus 22. And there we have it.